Thank you for joining me today in our session, Powering the Next Wave of Generative AI Models with Google Cloud's Supercomputing Architecture. I'm Chelsea Chop, Outbound Product Manager Lead for AI and ML Infrastructure. And today we'll go through Google's unique AI platform advantages, introduce you to our new AI hypercomputer architecture, and then we'll dive deep into the heart of our architecture, our cloud TPUs and our cloud GPUs. Generative AI models are rapidly becoming more sophisticated and capable, enabling enterprises across a wide range of industries to solve complex problems and uncover new opportunities. However, as Gen AI models have grown in size and complexity, so have their training and inference requirements. Larger models, up to hundreds of billions of parameters, can take months to train on specialized hardware. In fact, the number of parameters in LLMs has increased 10x per year over the last 5 years. As a result, consumers need AI-optimized infrastructure that is both cost-effective and scalable. In addition to the specialized hardware, you also need access to fully integrated AI stack with storage, networking, software, and framework that's optimized for your AI workloads. And that's why here at Google Cloud, we've looked at each and every workload and then designed and optimized a system-level compute, storage, and networking systems across hardware and software to be able to meet the unique needs of each workload. As a result, we can uniquely deliver breakthrough gains on the outcomes that you care about for your unique workload. So in today's session, we're focused on AI and ML workloads and how we've optimized for your workloads needs. Google is uniquely positioned to address the needs of your AI workloads. Our pioneering AI research and development is driven by more than 3,000 expert researchers. We've produced over 7,000 research papers. We've invented some of the most important AI technologies that fuel the current revolution, like transformers, compute optimal training, and optical circuit switch networks, and even application-specific chips such as tensor processing units, or TPUs. Our innovation extends to highly accurate and efficient AI models such as LLMs like Palm and Lambda, which are integrated into and empower our real-world products. Our software leadership directly empowers our valuable products that we've created. And to do that, we've created some of the most popular open source software projects in the world, like TensorFlow, Kubernetes, JAX, or XLA. And we're proud to say that since 2022, Google has been the largest contributor to open source according to the Open Source Contributor Index. And we will continue to invest in these diverse software initiatives and make them even better and more well-supported for enterprises. Our world-class infrastructure enables enterprises at massive scales. We operate some of the largest and most efficient data centers in the world with innovations in advanced liquid cooling technologies, optical interconnects, and dense data center designs. Customers can capitalize on our infrastructure leadership to quickly deploy AI solutions and products reliably, securely, and with high scale, and also to keep sustainability in mind. We have proven expertise in taking AI into production, as demonstrated by our 20-plus years of integrating AI innovations into large-scale applications such as YouTube, Maps, Search, Ads, Workspace, Photos, and many more. AI is truly in our DNA. We are fortunate to be able to work with thousands of customers across many industries to help them leverage AI for their specific use cases and to enable them to transform their businesses. From 70% of the top Gen AI unicorns running on GCP to powering Major League Baseball StatCast to helping do drug discovery and protein folding, we're able to power your unique AI workload need. At Google, we are building the industry's most advanced cloud AI platform by listening to our Gen AI users' needs. There are 3 main users that we see: foundational model producers, those who need the best training speeds and the leading AI frameworks; foundation model tuners, who also need speed, but also the ability to easily integrate data and storage across the platform; and then foundational model consumers that need the lowest latency serving and the best cost per inference. We have the most comprehensive AI infrastructure that is designed to meet the needs of every AI workload and every customer type, from foundational model producers to tuners and consumers. So working from the bottom up here, it starts with our leading cloud TPU and GPU accelerated computing options, which are complemented by a broad range of AI-optimized storage and data integration options. We bring these together in a supercomputing system with scalable networking, offloads, and state-of-the-art water-cooled data center system design, and more. We make it very easy to consume with support for both GCE and GKE, Google Kubernetes Engine. And with that, we deliver unique value with our software, enabling training and serving workloads across multiple systems, complemented by open high-performance frameworks, compilers, and more. And finally, Vertex AI at the top, we make it easy to integrate and serve Google models and partner models in your applications. And we are thrilled to introduce our new AI hypercomputer architecture, a full-stack AI-optimized hardware, software, and consumption options, working together to improve AI workload performance, scalability, and also cost efficiency. The AI hypercomputer architecture consists of 3 layers. First, performance-optimized compute, storage, and networking over ultra-scale data center infrastructure. Second, software. You have tuned and optimized, which are dynamically orchestrated AI training and inference. And then third, you have flexible consumption models and dynamic resource scheduling, including dynamic resource scheduler that we'll talk about next. And this framework is built on decades of Google research. The elements of hypercomputer work together to help improve system efficiency and ease with which that you can orchestrate and consume our services. One of our latest capabilities in optimizing your specific AI needs is in scheduling. We're really excited to introduce Dynamic Workload Scheduler, DWS, designed to help obtainability and scheduling capabilities across accelerators. There are 2 modes of scheduling. You have calendar and flex start mode. Calendar mode gives you assurance on having that capacity when you need it for a given project. And flex start runs the job based on obtainability and availability to give you better economics and to make sure that you get that job running. So let's dive into the heart of the hypercomputer architecture, which is down to the hardware level. This year, we've been really proud to introduce our 5th generation cloud TPUs, which are purpose-built AI supercomputers. We've had rapid innovation with our cloud TPUs, and TPU stands for Cloud Tensor Processing Unit, and it is one of the fastest, most efficient, and sustainable machine learning systems in the world, designed by our own engineers here at Google. A cloud TPU is one of the key differentiators not only for Google Cloud, but for entire Alphabet, and here's why. Many of Alphabet's key products from Search, YouTube, Translate, Gmail, and many of our state-of-the-art Gen AI models such as Lambda, Palm, and Gemini are powered by our cloud TPUs. Externally, we see rapidly growing systems of ML practitioners who are actively using and utilizing TPUs to push the boundaries of AI in a very cost-efficient and sustainable manner. And even more importantly, our customers are now enjoying a much better ease of use with our recently launched TPU VM architecture to be able to employ an ML framework of your choice, including JAX, PyTorch, or TensorFlow. So today, we're really excited to announce Cloud TPU V5P, our latest 5th generation TPU in preview. TPU V5P is known to be powerful, scalable, and flexible. It's our most powerful TPU to date. You can leverage V5P to compress your AI model development time from months down to weeks. In fact, it's 2.8 times faster at training LLMs than previous generation TPU V4. And with our 2nd generation sparse cores, train embeddings-heavy models get up to 1.9 times faster. TPU V5P is also 4 times more scalable than TPU V4, and it offers the state-of-the-art optical switching technology that enables the world's highest bandwidth chip interconnect at 4,800 gigabits per second per chip over a 9,000 chip domain. In addition to being powerful and scalable, TPU V5P is also highly flexible. It can enable training on a diverse model architectures such as LLMs, mixture of experts, and recommendation systems, among many others. Meanwhile, it also features 3x higher bandwidth memory, making a versatile enabler of workloads that would otherwise be memory constrained. V5P is actually a marvel of engineering when you look at each pod features and size. Each TPU V5P pod has an astounding 8,960 chips. And by using our multi-slice training software, you can achieve impressive training scale and do training workloads to tens of thousands of chips per run. And earlier this year, we announced TPU V5E, focused on providing the most efficient and versatile offering in our TPU portfolio. Let's take a closer look at the last iteration of the TPU V5E. First is cost efficiency. V5E provides 2 times higher performance per dollar when training large generative AI models and up to 2.5 times higher performance when running inference on them. Second is versatility. In addition to running both training and inference, TPU V5E offers 8 different VM shapes to support the full breadth of LLM and Gen AI model sizes. You can go up to as large as 2 trillion parameters. The diverse VM shapes offer a wide range of computing horsepower and memory capacity, which allows you to choose the optimal shape to suit your AI model needs. And because it's a TPU, it's designed to scale. Using our latest multi-slice technology, you can easily scale model training across tens of thousands of chips. Additionally, you can conveniently leverage the same exact out-of-the-box XLA programming model to scale that you use today. So what does that all mean? 3 things, really. You can train and serve faster, more affordably, and more productively. Who doesn't want that? So I know you're craving to see the details of the TPU V5E architecture, and here it is. Now, one thing to note, V5E is not the largest TPU that you've seen, but it is in fact the most efficient TPU to date. In a world where we're confronted with the global AI chip shortage, we've changed the way that we've thought about serving our customers. So we have chosen to make every single chip count. Recently, we ran an impressive experiment to scale up to one of the world's largest distributed training AI jobs, spanning more than 50,000 TPU V5E chips. We achieved this by virtue of our incredible multi-slice technology that has deep integration with Google Kubernetes Engine, and also by leveraging accurate quantization technology and int8 precision format. We've published the specific reference collateral for anybody that's interested to learn more or to even try it out yourself. And we wrote up a blog detailing how you can do the same. We're also bringing the high throughput and low latency inference to cloud TPU V5E. With optimizing our OpenXLA compiler, Cloud TPU V5E delivers up to 2.5 times higher throughput per dollar for a range of state-of-the-art LLMs and Gen AI models, such as Llama 2, ChatGPT-3, Stable Diffusion 2.1, and Gemini. By the way, we can do this while achieving throughput performance without sacrificing latency. In fact, TPU V5E achieves up to 1.7 times increased speedup over our prior generation V4. So what does this all mean? It means when it's all said and done, you can bring your most accurate and capable AI models to real-time production applications at just a fraction of what you'd otherwise pay. So whichever 5th generation suits your needs, we've invested in a complementary software stack to support your needs. From leading AI frameworks such as PyTorch, TensorFlow, and JAX, now you can train and serve models end-to-end on TPUs. As I said, what you train is what you serve. TPUs are also fully integrated with GKE, enabling seamless workload orchestration. Furthermore, we have integration with Vertex AI, which brings fully managed training and prediction workflows. This combination of elegant hardware and out-of-the-box software provides a cost-efficient and productive end-to-end AI development platform for your needs. And here are the specs that you can see across our 4th and 5th generation at a glance. You can see we've dramatically been able to scale the TPU V5P pod over prior generations and also improve chip efficiency. So with that, you can really see how we've been able to achieve these new breakthroughs. And we have a diverse number of customers across different use cases, leveraging both V5E and V5P to power their state-of-the-art AI models. So with that, we'll move on to cloud GPUs powered by NVIDIA. We have prided ourselves in having a history of being first to market since our first T4 and T4 offerings to accelerate ML inference. Earlier this year, we were the first cloud to launch G2 powered by NVIDIA L4 Lovelace, and these advantages that make Google Cloud customers enjoying our platform are significant. The cost to serve model can make or break a Gen AI business model. In our fast evolving commercial landscape, we have one of the best serving hardware like L4 can put you ahead of your competitors, getting you the best inference per dollar. We also have a breadth of offerings. We provide optionality for your unique workload. We offer 9 different NVIDIA GPUs with flexible shapes to help you optimize cost for your specific use case. And this holds true from graphics to your largest large language models. And I previously went through how AI is in our DNA and how we bring those capabilities to our cloud platform to create a truly end-to-end cloud AI experience. With our GPU offerings on Google Cloud, Google focuses on the added value we bring to our customers on top of the amazing NVIDIA hardware. We have performance and adaptability, Google systems that help you manage failure and optimize your goodput, while having peace of mind on security, and your software stack optimizations with frameworks such as JAX and OpenXLA on GPUs. We also have scale and elasticity. You can scale to tens of thousands of GPUs in tandem connected with high-speed fault-tolerant networking. We also have a breadth of AI cloud experience of providing orchestration, security, manageability, and integration with AI-first services such as GKE and Vertex. And of course, this is all underpinned by the offering of the best NVIDIA has to offer. We have a first-class GPU offering of NVIDIA on Google Cloud. Our current generations include the H100 and L4. The H100s are able to power your largest scale AI workloads, or HPC, and L4 is able to power your Gen AI and graphics. And with that, we have deep support integration across our entire Google Cloud portfolio. Our A3 VM is our most powerful GPU offering. Powered by NVIDIA's H100 GPU, it's a leap forward in supercomputing capabilities. We were able to achieve 10x increase in networking and 3x increase in training performance over A2. Our unique intelligent Jupyter data center networking fabric enables us to scale to tens of thousands of interconnected GPUs. A3 is also able to operate at scale, scaling to tens of thousands of H100 GPUs. A3 scale is able to provide up to 26 exaflops of AI performance, which improves time and cost for training and serving large AI ML models, or to power your most demanding HPC use cases. A3 is already trusted by Gen AI unicorns who are revolutionizing their industries. And earlier this year, we announced G2 VMs. We were the first cloud to offer NVIDIA's L4 GPU, and our G family is named for Gen AI and graphics. It's our most versatile GPU offering and is able to power a broad range of use cases from Gen AI to virtual workstations or gaming. G2 is a follow-on to our T4 offering and is able to provide 2 to 4x performance improvements depending on your workload. So let's take a closer look at those numbers. For Gen AI, we saw a 2.5x performance improvement. In gaming, a 3.3x improvement. And for powering large digital twins, we saw a 4x performance improvement. And we've had rapid adoption amongst a diverse set of customers. To name a few, Volkswagen uses G2 to power their virtual show station. And Bending Spoons achieves lower latency and is able to scale up to 32,000 L4 GPUs. And Midjourney gets a 15% efficiency improvement using G2 VMs over T4. We have a comprehensive portfolio of purpose-built AI acceleration options from cloud GPUs and cloud GPUs to meet what you need for your specific AI workload. Well, thank you for joining us today and learning more about our latest innovations in AI hypercomputer architecture. We look forward to powering your next Gen AI workload. Enjoy the rest of the summit.